Hello everyone, I am Pratibha Prabhugaonkar, Assistant Professor at Dampe College of Arts and Science, Miramar, Panji, Goa. This module is for third year BSc Botany students. Course code is BOD 104 and title is Biofertilizers. Title of the unit is Phosphate Solubilizing Microbes. Name of the module is Phosphate Solubilizing Microorganism, Mass Production, Field Application and Crop Response. In this module, we will study the mass production of phosphate solubilizing microorganisms, their field application and crop response to phosphate solubilizing microbes. At the end of this module, you will be able to explain about the mass production of phosphate solubilizing microbes, field application of phosphate solubilizing microbes and their crop response. Mass production is production of any organism, any microorganism in large scale. So these phosphate solubilizing microorganisms are mass cultured by using Pekovskaya's liquid medium in large bioreactors. Bioreactors, they are the large vessels which have the requirements for agitation, aeration, temperature and pH control, etc. So once the medium is prepared in the bioreactor, the medium is autoclaved and after cooling the medium, 1% of the starter culture is inoculated into the bioreactor and temperature is maintained at 28 degrees Celsius for 7 to 17 days. Starter culture is the culture which is prepared after purifying the colonies from agar medium, and the starter culture is prepared by adding a small amount of purified culture into a liquid medium into the small flask. After inoculation into the bioreactor, when the culture attains 108 cells per ml, it is harvested to make a carrier-based inoculant. So you can see here, this is the bioreactor which has a large vessel in which the medium is added. The medium is sterilized and then the inoculum is transferred into this medium. And this bioreactor, it has requirement for agitation, for temperature control, pH control, etc. Preparation of carrier-based inoculant. Wood charcoal, peat or mixture of wood charcoal and oil are used as carriers for the inoculum production. A proper carrier is selected first. After selection of carrier material, it is powdered, neutralized and sterilized before mixing it with the harvested inoculum. This harvested inoculum, it is from the bioreactor. For neutralization of the carrier material, either calcium carbonate or organic matter is used. Neutralization meaning the pH is brought to 7. If pH is acidic, calcium carbonate is added to the carrier material, and if pH is alkaline, organic matter is added to neutralize the carrier material. After sterilization, the inoculum is added to the carrier and mixed well till the carrier attains 40% moisture. Inoculant is left as such in the sterile mixing chamber for a week for curing. Curing is a process which involves chemical reactions and physical actions for stabilizing the product. The inoculant is then filled in a low density polythene bags and stored at 15 to 20 degrees in a cool room for sale. Coming to the field application of these phosphate solubilizing microorganisms, this phosphate biofertilizers, it is diluted with water and then treated with gum arabic and calcium carbonate to make a slurry. And the seeds which are to be sown are soaked in the slurry for some time and dried in shade. By this process, the inoculant is made to form a pellet on the seed. Seeds are then sown in the main field. Crop response to phosphate solubilizing microorganism. A significant increase was observed in crops like wheat, rice, maize, chickpea, pigeon pea, soybean, groundnut, etc. Significant increase was also observed in soybean yield due to inoculation with the phosphate solubilizing microbe, that is Bacillus polymixa, along with the rock phosphate application. In the trials which were conducted with different crops, increased yield were obtained due to inoculation with culture with or without rock phosphate addition. Potato tuber yields were increased by 50 to 60% due to the inoculation with the fungus, that is Aspergillus avamori, Penicillium striatum, and the bacteria Bacillus polymixa. Phosphobacteria solubilize the bound phosphate and contribute to 20 to 30% of phosphate which is required for the growth of crops. Phosphate biofertilizer is suited for all types of crops. In groundnut, the bacterium Bacillus megaterium together with rhizobium, it boosts the yield up to 28%. Aspergillus avamori, it increases the groundnut yield up to 25%. By providing 10 kg of phosphobacteria per hectare, phosphate fertilizers can be avoided for sugarcane. Co-inoculation of Bacillus megaterium and Pseudomonas striatum with Azotobacter crococcum increases the yield in rice, sorghum and cotton. These are my references. Thank you.